Hi, in this video we will be discussing the indefinite integral. Okay, so an indefinite integral, or integral, which is also known as the antiderivative, is obviously the opposite of differentiation. So integral calculus is the opposite of differential calculus. In differential calculus, we are given with a function and we are asked to solve for its differential or derivative. But in integral calculus, we are given with the differential and then we solve for the original function. Okay, so it is denoted as this. So capital F of x is equal to the integral of small letter f of x dx. Okay, so where f of x dx, that is the differential. Okay, and capital F of x, this is the um, integral or the original function. Okay, so the result of integration is called the integral. This sign is obviously the integral sign. So whenever we see the integration sign, so we are asked to integrate, and the function inside the integral sign is called the integrand. Okay, so it's a differential, so it always has a differential variable at the end. Okay, so we can only integrate an integrand if it's a differential. Okay, so as I've said, the integration is the opposite of differentiation. Okay, so if we are given with a differential, then we solve for the original function. So say for example we have a differential of 3x squared dx. Okay, so we are given with this differential and we want to find the original function. Okay, a function for which it has a differential of 3x squared. So knowing our knowledge in differential calculus, so we can see that a function with a differential of 3x squared must be x cubed, right? So therefore, the integral of 3x squared dx is x cubed. Okay, for which we can check that by differentiating again the function. So if we differentiate 3x squared, its differential should be, if we differentiate x cubed, okay, if we differentiate x cubed, its differential should be 3x squared dx, right? Okay, so another thing about the indefinite integral, so whenever we perform integration, so there is an arbitrary constant that we don't know. Okay, so it is denoted as c. Okay, so this constant is a constant that was omitted when we performed differentiation. Okay, and we don't know the value of that constant. So all we know that when we differentiated a function, so there was a constant that was omitted because the differential of a constant is 0. Okay, so that's why whenever we perform integration, okay, especially if it's an indefinite integral, then we must add an arbitrary constant c. Okay, so that's the concept of the integral calculus. So the general properties of integral calculus. So we have this one, these three. So the integral of du is equal to u plus c. So it just means that every time we perform integration, there is an arbitrary constant that must be added. Okay? So that arbitrary constant, again, was the constant that was omitted during differentiation. Next is we have integral of du plus dv plus dz is equal to u plus v plus z. So it just means that whenever we perform integration, so all we need to do is integrate each term. Okay, so if our function or our integrand is composed of 3 or more terms, then all we need to do is distribute the integral sign for each of the terms. And then the last one is we have integral of c du is equal to c integral of du. So this means that whenever we have a coefficient, a constant coefficient in the integrand, then we can take that out of the integral sign and write it as a coefficient instead outside the integral sign. Okay, so the constant is not included in the integration, so we can simply transfer that outside the integral sign. Okay, so the power formula, so we are familiar with the power formula in differentiation. Then this power formula is the power formula for integration. So the integral of x raised to the n, integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1 plus c, where n is not equal to negative 1. Because if n is equal to negative 1, then the denominator here will become 0 and the expression will be indeterminate. Okay, so it's that simple. So all we need to do is memorize those properties. Okay, so example, so we have evaluate the integral of 6x cubed minus 4x plus 1 dx. Okay, so in integrating this, so all we need to do is follow the properties, general properties. So first property, we can use property number 2. So we have here a integrand consisting of 3 terms. Then what we can do is distribute the integral sign and dx. Okay, so this will become integral of 6x cubed dx minus integral of 4x dx plus integral of 1 times dx, so integral of dx. Okay, so the next is we can use the third property. So we have a constant coefficient on the first and second term. So this 6 is constant, 4 is constant, so we can write them outside the integral sign. So we'll have 6 integral of x cubed dx minus 4 integral of x dx plus integral of dx. Okay, so now we can apply the power formula, x raised to n. So here our n is 3, and for the second term our n is 1. Okay, so we can follow this formula, x raised to n plus 1 over n plus 1. So we will have 6 times integral of x cubed dx, so that would be x raised to 3 plus 1 over 3 plus 1. Okay, minus 4 times integral of x dx is x raised to 1 plus 1 over 1 plus 1 plus integral of dx, so that is x, and then plus. Whenever we finish integrating, then we must add an arbitrary constant c. Okay, so therefore, simplifying, so we have 6 over 3 plus 1, so we have 6 over 4. 6 over 4, if we simplify 6 over 4, that will be 3 over 2. So we have 3 halves x raised to the power of 4 minus 4 divided by 1 plus 1, so 4 divided by 2, that will become 2, and then x squared, and then plus x, and then plus c. Okay, so that now is our answer. So this is the integral of this. Okay, so to check, so we can apply differentiation. So we can differentiate this, okay, and it should go back to the original integrand. Okay, so I believe you are good with differentiation, but let's try. So the differential of the derivative with respect to x, so let's take the derivative of 3 halves x to the fourth minus 2x squared plus x plus c. So this is equal to, this is only for checking, so that is equal to, so 3 halves power formula of x to the fourth, that is 4x cubed minus 2 power formula of x squared, so that is 2x plus derivative of x with respect to x, that is 1, and then plus derivative of a constant, that is 0. So therefore, this will become, so 3 halves times 4, so it will cancel out 2, and then we will have 3 times 2, so it's 6x cubed minus 2 times 2, 4x, then plus 1. Okay, so which is this. Okay, so that's it. So all you need to do is do it step by step. Okay, so term by term, you will integrate. Okay. Okay, so another example. So we have the integral of square root of t minus 1 over square root of t. So for us to apply the power formula, so we need to express the radical, okay, the radicals into exponential form. So square root is equivalent to an exponent of 1/2. Okay, so rewriting, so we have integral of t raised to 1/2 minus 1 over t raised to 1/2 dt. Okay, and we need to express the variable in the numerator. So we have integral of t raised to 1/2 minus t raised to the negative 1/2 dt. Okay, so with that, we can now apply the power formula. So but first, distributing the integral sign. So integral of t raised to 1/2 dt minus integral of t raised to the negative 1/2 dt. So now we can apply the power formula, where n in the first term is 1/2, n in the second term is negative 1/2. So we will have power formula, so t raised to 1/2 plus 1 over 1/2 plus 1 minus t raised to negative 1/2 plus 1 over negative 1/2 plus 1. And then after performing integration, so we must add, we must not forget, so plus the arbitrary constant c. So this will become this will become t raised to 1 half plus 1, that is 3 halves, over 1 half plus 1, that is 3 halves, minus t raised to negative 1 half plus 1, so that is t raised to 1 half, over negative 1 half plus 1, that is 1 half, plus c. And then simplifying, so we have 1 divided by 3 halves, so that will become 2 over 3 t raised to 3 halves minus 1 divided by 1 half, so that is 2 t raised to 1 half plus c. Okay, so this is an acceptable form of the final answer already, or you can express it back into radical form. So t raised to 3 halves, that is t times t raised to 1 half, so that is 2/3 t square root of t minus 2 square root of t plus c. Okay, so again, you can check it by differentiation. So after differentiating this, so it should go back to the original integrand, okay, expression. Okay, so that's all for this video. So there are exercises for you to answer, so kindly answer them.